the US government will pay even more, and I am sure that any government in the world will pay even more to zero-day security breach. Let me tell you a story. About 5 years ago, I was sitting by a nearby computer, developed some sort of very simple, maybe not so simple, but a C# code using .Net, and there was a bug there. The program crashed. And I simplified the code, you delete all the stuff, you create a simple test case, and it still crashed. And it wasn't my code, it was .NET code. I mailed it to my friends, I asked them, is it me or is it .NET? They said that nothing is wrong with my code. And 7 months later, I got this recognition that I found a zero-day breach, a code that can cause to attacker to take control of your machine. Actually, if I knew that the bug that I found is these kind of bugs, I could, you see, the remote code execution can give you like something like $300,000 if it's in Windows. So I didn't get the money, I did a good reputation. And sometimes people say that the name is more important than money. I'm not sure that my wife will agree with it. But this is the story of a real bug. So my name is Alon. I'm the chief software architect and founder of Code Value, a software company. I'm also a Microsoft Regional Director and Microsoft Azure MVP. Code Value is a software house, and we do many kind of projects, but the one that we are very proud of, and I'll show you today, is Ozcode, which is an extension for Visual Studio that lets you debug in much better way. So we will talk about debugging, how you do it in the correct way, how you can save time, how you can control the debugger, what is a debugger, and I'll also show you Visual Studio debugging, some advanced techniques, and Ozcode. So I call it the art of debugging. And I'm not talking about, simple debugging when you write code or test and just see that your variable is not okay. I'm talking about the real hard bugs that are very, real hard to find and solve. So to understand and solve bugs, you need to sometimes be even better than when you develop your code, because usually when you develop code, you use an abstraction layers. You don't get into the inner layer. You don't need to understand the operating system, you don't need to understand the hardware, but when you do a debugging, you need to have a technician senses. You need to understand everything. So it's a knowledge, it's how to use the tools, and in how to make hypotheses, and it's how to solve what I call put the bug in the corner and solve the problem. And you should do it in a systematic way. First of all, you need to understand the context. Is it a bug or is it a feature? Maybe this is what they wanted. Then, very important, you need to reproduce the bug. You need to create the test case that shows the bug. And this is sometimes something which is very hard to achieve, especially those production time bugs that you can't very easily reproduce in the lab. Then you need to simplify the test case, get rid of code that is not related to the bug. You need to understand the error. You need to check the obvious. You can't write to read-only file. You need to collect facts, and you need to separate facts from your interpretation, because it may lead you to a dead end. So write down all the facts that you found. You can use techniques like divide and conquer, like cut your code to 2. It's very easy if you write the test before and your code is testable. It's very hard if the code is monolith, that's very hard to break. So good software practices is always, helpful. You need to use the right tools. Don't do many changes at a time. Usually when you solve a bug, you think about what can happen and what can I do to understand the problem. And then you find several ways to do. So do them one by one, because if you do like many different changes and the bug goes away, So now you need to redo everything and do it one by one. Do it from the first place, one by one. Consult others. Sometimes just by telling about the fact that you found, you will yourself solve the bug. Because you put it in order. You think about stuff again. Consult the web. Do a search. Okay, sometimes it's not just your bugs, it's bugs that others also found. There are known bugs. Ask people. If the bug somehow disappeared, something happened. It will return. For example, the time has changed. There was a software update, but maybe on the production machine there is no this kind of software updates, and the bug will reappear. So understand what happened. Use source control so you can go back to the code before and see the differences. Now, debugging is a waste of time. Actually, we as a company create this tool that lets you debug in much easier way, and the thing that we want is that you don't use the tool. So if we can save you time, we save you money. Okay? How do you usually waste time when you do a debugging? You restart the debug instead of go directly to the position that you can find the problem. Okay? You do a single step instead of putting a breakpoint or somehow be in the state that can reveal the problem. Okay? And I want to show you how you can do it much faster. So let's sum up the opening part. It's like any other development skill. You need to be skillful when you do the debugging. You need to be in order, be organized, and you need to understand the system and use the right tools. Then we talk about .NET debuggers, but I will focus on Visual Studio.NET and I'll show you tools, but many of the things that I say also correct for other debugging, other software tools and techniques and programming language and so on. So for .NET, Visual Studio is probably the best debugger. It's even better when you deploy Oscode. There's also another tool which is the NDBG. How many of you are using C#? Okay, good, great. Do you know about MDBG? It's a command line debugger that you can download and use, currently only for the full .NET framework, not yet for the .NET Core, but it will be probably available, I hope, also for the .NET. Actually, I think the source code is there, but they don't compile it to the .NET Core. Probably they need some API that are missing there. But you can use MDBG to do a command line debugger. You can also write debugging scripts using MDBG. It lets you put breakpoints, do a single step, or everything from the command line. So download, do the help, and see the commands. Another option is WinDBG. Who knows about WinDBG? Okay, WinDBG is the Windows debugger. It's a debugger that was invented by the Windows team, the team that created Windows, and it's built with a basic debugger and a layer of extension DLLs. Each exported function from the extension DLL is another debugger command. And the .NET team created the SOS DLL. It's the son of Strike DLL. And this DLL gives you .NET commands to do a .NET debugging. Now, it's not so easy. It's command line. You need to understand all the different switches and flags and so on. But it is a very powerful debugger. If you need to know what really happened inside the .NET framework, inside the CLR. Okay? SOS XDLL is another extension for WinDBG. This comes from the community. Okay? And it also extends WinDBG with other features like finding deadlocks in .NET, looking into the GC, and so on. Now, the question is, what is a debugger? And actually, the debugger in Windows, it's something which is baked into the system. There are API. If you need to write a debugger, there are APIs for you. And usually, this is what debugger does. You start the debugger, the process that is being debugged, okay, from the debugger, or you can attach to a running process. There are API to do both. Then you enter a debugger loop. Now, the debugger loop is something that you wait for a debug event, Debug event might be exception, creating new thread, exit thread, creating new process, loading DLLs, unloading DLLs, write to logging to the debug output string. So if you write to a log, it's also a debug event. Whenever there is a debug event, the debuggy stopped, and the debugger get out from this wait for debugging event API, gets the event code and the event information. And this is where usually Visual Studio stop, and you can now look into variable values and this kind of stuff. Once you finish, you do the F10 or F5, right? You continue to run. So this is the continue debug event API. Okay? So this is the basic code. It's a C++ code of a debugger. And instead of showing you the code in slides, I decided just before this lecture to write a debugger code just to show you how debugger works. So I have here a C# code. This is the debuggy, the program that I want to debug. Is it big enough? You can see. Great. You can see that I write to the diagnostic debug started. I have an internal breakpoint, okay? Then I write that I'm between breakpoints. Then I invoke two tasks which actually will create threads in the system. There is a thread pool underneath. I do an exception, I divide by 0, but I catch it. And of course there will be DLL load and unload, process exit, and so forth. The debugger itself create new process, okay? And it creates it with a new console, but it says that it needs to debug this process. When it says only this process, it means it doesn't want to debug child processes, okay? So this is how you create process under a debugger. Then you enter a loop, and you wait for debug events. Okay? Once there is debug events, you can ask for the debug event code. And here, according to the debug event code, if it's a new process, if it's a new thread, I write the thread address. If it's exception, I also switch for the exception. If it's breakpoint, I write down that it's breakpoint. If it's divide by 0, I write down that it's divide by 0. If it's exit process, I write it down. If it's exit thread, and so on and so forth. And you can see that for the debug string, I also print the debug string. And the way that I do that is that I get the address and I read here, I read process memory, I read the address of the debugging process to get the string from the other process to my process. So this is the most basic debugger that you will see ever, right? It's not a real debugger, but it writes all the events that happened, okay? And let's run it. So let's put a breakpoint. There is a breakpoint here. Let's put also breakpoint here. And maybe let's see the exception maybe. And here. So let's start it. It's already there. Okay. So we are starting now in the message loop of the debugger, and we wait for debug event. We got one. It's create process. It's the first one, right? So let's run and let's go continue on. Let's remove this breakpoint. Okay, now we stop in the exception. Let's see the output for so this is the program. So this is small. I try to make it bigger. Okay, so you see the different DLL, the executable, and so on. Okay. Let's continue. So now we are in the exception, and we see that it's a breakpoint. Okay, let's continue. Another exception, probably the second breakpoint, or something else. That was the divide by 0, and you understand the point. So let's continue and see the result. So you see the new threads, the exception points, the DLL load and unload. Okay? So now you understand what is a debugger. And if you want to write one, you know how to start at least. Then you need to know how to load symbols, how to get to address location. It's not so easy, but you get the idea. Okay? It's baked into Windows. Okay. Great. Now, if you want to write a .NET debugger, you don't need to go to the Windows API. There is an interface just for .NET debuggers. A debugger that understands the GC, the CLR, and everything. And actually what they do, they wrap those lower layer API and provide you, it's still C++, it's a COM object, but this is to develop .NET debugger. And if you want to extend Visual Studio, you get another mechanism, okay, which the name is Concord. It's open source. Most of it is open source, and actually in Old Code we use it. And you can change many different stuff that Visual Studio does in the debugger, okay? So you see that there are layers from the API to .NET to Visual Studio. Now, when you do a debugger, you can be like this lady. You can press F10, F10, F10 until you reach the point. Or can you smile like this lady and be in control? And I want you to be in control. I want you to save time. So how do you do that? You use the tools. You put conditional breakpoints specifically in the condition that you want to test, right? So you will stop in the debug events when the state of the software is the state that you need to test. So conditional breakpoints is a very good way. You can also break on a function. Even if it is not your function. You can put a breakpoint on a function. You want to search for who did this allocation, who did this. So just put a breakpoint in the function, go to the call stack and see who did what. Okay? Now, I'm not sure that you know, but in Visual Studio, and let's go to another example. In Visual Studio, you can even change the current execution context, which is the place that you stopped the execution, where the debug event was. You can change it while you are in the stop state. So, for example, let's run a server-side code. This code just read a message and write it or send it back. This is the server side. Let's run it under a debugger. And a client side which just called this server side. So I will debug two different processes. Okay, a client side. What did I do? Started a debug, which is okay. Okay. All right, so there is again internal breakpoint. I stop here. And if I go to the call stack, I can see that I stopped in this function. And now I can look at variables, values, and so on, but I can also double-click the previous stack location and go to a previous stack location and check things here. Okay? Or I can go to debug Windows and ask for the threads window and change the different threads. I will make it a bit bigger so you can see. So you see, I'm now in the main, this is the server side, this is the client side. I can jump between them. I can jump to this main thread, and now I'm in different location. Let's give some. Okay, so I can jump between threads. I can even change the thread's name if I want to understand where am I and so on. I can rename a thread. Okay? So you can jump between processes, between stack location, between threads. You don't need to break there. You can just move there. Okay? You can also change the execution point. Let's go out from this and close this. So you can, if you want to jump and not execute a command, you can just move the instruction pointer. And yet now I didn't execute this command, or I can go back and re-execute the command again. Okay? So you can actually control everything that you do. Of course, the state is something that you need to be aware of. You can also change the state. You can decide that the message should be something else. Okay? So you can be in your specific state that you need to check instead of, continue and doing F10 until you get to the point. Okay? Great. Okay. So there are those moments in life. Okay. So did you see Oscode? Anybody here use Oscode? Great. So this is the moment in your life. So let's look at Oscode. So we developed Oscode because we thought that people spend too much time in the debugging and it's not so easy to understand what's going on, and we need a better tooling. Let's set this to be the starter project. So Oscode demo is something that is installed when you also install Oscode, so you can play with it. And this is that a demo that helps you to check the different options of Oscode. And let's start with simple options. So one of the best things that Oscode does for you is it shows you the result of expressions. So you see that the result of this expression is going to be, it's before the execution, it's going to be 256. Okay? And if you, just a second, if you press on this icon, you can see the different values that make it happen. If I continue to single step, you can see that for out variables, I see the before and after. Is it big enough back there? Again, an expression that you see, that you can see the different parts, the before and the after. A ref variable, okay, before and after. And the return value from a function. Now, if you go to a customer, let's try something else. Let's do it in a faster way instead of breaking each time on the breakpoint. Here I have a list of customers. And if I open the list, you don't see anything about the customer because nobody implemented the toString for the customer. But if you use Oscode, and you can then tag different properties, like the full name and the edge, which has some bugs. And now when you look at the customer, you see the value that you tagged. Now, whenever you go now to a customer, Oscode will show you the specific customer. Great. Just this saves so much time. You can also search. For example, I can search for the name, and I can see all the properties that has this text inside. Also, I can search for values. and I can search deeper in the object tree. Cool. Okay. Oscode lets you put breakpoints in a nicer way. Oscode also help you when you do an exception, when you need to deal with exceptions. So for example, here I have an exception, and you can see that I can open this dialog and see the exception, and if there were inner exception, you see all the inner exception. And one thing that you usually do when you have an exception, you go and search for the exception value of code in the right locations, and also to be politically correct with Microsoft, we added Bing. But it's the last one. Actually, it was I asked for as a regional director, you know, I had to. Which is cool, right? Again, to save time. Okay. Let's go on. So now, usually what you do when you do a debugging, you collect evidence, right? You need to find the root cause, you collect information. And sometimes you want to share this information with other person or just to write them down. So one thing that you can do using Visual Studio, even without Oscode, is, let's go to one of the demos, doesn't really matter which one, let's go again to this one. So what you can do, you can open the immediate or the command window. The immediate window is the one that you can do everything that you like. It's like a shell to execute code. You can call functions. And what you can do, you can execute commands. This is like the command window. If you use the angle brackets, now you execute commands. And one of the command is the log command, which is actually an alias, okay? And you can say log on and give it a file. ctemp log txt. Now, whenever you do here, it goes to this file. So if I just, you know, add something, if I go to customers first, it's a customer already. Where am I? Customers, not customer. Customer dot first, for example. Okay, so now the customer is here. And if I now go to log off, I stop the log, and I can even use the open command to open this file. You see that you also get the help from the editor, and now this is everything that I collected. Cool. Very easy. Okay? So you have it in Visual Studio. Okay? You can use Oscode to do the same, but in a much nicer way. So let's go again, and let's look at the customer. And what you can do with Oscode, you can go, make it a bit bigger, you can go to this magic wand, and you can ask it to export. And when you export, you can get it in C#, in XML, or in JSON. So think about, you get to this step that you know that there is a bug, and you have the test case, right? So now you export the object and put it in your test. Very simple. And if you need to go deeper, you can ask to choose a different level. So now you see that the birthday has more values. Okay, or to go less in the details. Okay. This is only 2 levels. Okay. Very useful. Then you can compare, but actually for compare we have also another feature that I'll show you. You can use trace, you can use filter. For example, to save time, I just put the animation here, but you can filter or you can add custom expression to collection. So here I add a new property just for the debugging purposes. I give it a name and I get new property. Okay? Here I want to filter a large collection. It's the customer collection. I edit a filter, give it some sort of expression, and now I filter the collection. So again, very handy tools. Compare. I want to compare two phone books instances. So Oscode helped me to find other types, other instances from the same type. And now I can ask it to compare and see if they are the same or different, and also to show me the difference between the two. So, and I can also save an object which is like an exporting, but we save it in memory and then compare to previous version. So before I add something to my shopping cart, I can take a snapshot, add, take again, and compare and see whether everything now is okay, whether I added all the information that I needed. Okay? So this is compare. Let's talk a bit about link debugging. So, do you use link? Some of you. Link is something which is very hard to debug, okay? But using Oscode, it becomes very easy. So here, I have a text, a poem, and I want to find a bug. I want to find how many times the word bugs appears. And if I step over, I see that it appears, the bugs is not the word that appears the most, but I thought that it should be the one. So I can go, and again, let's execute this link statement again. I can go and press here and see what's happened inside link. All the, don't show it again. Got it. So I can look at the word bugs, for example. Okay. I can see that there are 4 of them. 1, 2, 3, and 4. Okay. If I want to see it in extended way, I can open this window. I can ask for the word bugs and see that I have the 4 of them. I can go to the word clause. I can see that empty spaces don't continue. I see the word bugs goes to its own group. Let's go to the group by. So in the group by, I see that the word bugs go to its own group, but the word bugs go to a different group. So I see that the bug is that the word bugs, it's uppercase and has these parentheses at the end. Okay? So you have a very powerful tool to do link debugging. Okay? Okay. And this is the exception that says that we have a bug. We know that. We also let you do a search, and actually we are going to ship a new search that gives you Google-like experience. Okay, you see how many items, how many results in your code, and it's much faster. Now let's talk a bit about the future. Usually if you want to find those rare cases, you can use historical debugging. Historical debugging is something that collect information, and then let you go and rerun the code, right? We want to change it. We want you to use the debugger while you do the code, and to let you understand what is going to happen in the future with the code. Okay? So we actually want that development, testing, and debugging will be the same action that you do. and that you will do it all the time. So let's see this example. I don't hear the sound. Maybe it's my fault. No, never mind. I'll explain it. So we want to enter this image, to the tiny little hole here. So we need to find the right value for the velocity. Using a predictive debugging, we can see all the places that this image will be, and now we can change the value to see what will happen in the future if we somehow change our software. So I can play with it until I get to the point that I know that this is the correct value. Now I know that this is what's going to happen. And this is academic, right? I want to show you what we did, or what we are going to do with Oscode 4, which is not academic, but the tool that we are going to release. So these are the very first bits of Oscode 4. And I actually need to spawn a virtual machine for that because it's the very first bits, so I don't want to install it on my main machine. So let's start this virtual machine. So we now spend the time to build several new, I call it even new product, not just new features and tools. So, failed to start, why? You have to bring me the other computer, maybe it will work there. I have time out.
5 minutes left.
5 minutes. So let me show you it by slides, and then if you want, I'll give you a video in the web. So what we are going to do is give you this. When you go to a breakpoint, we will predict all the future. You don't need to do a single step. If you change the code, we will change the execution path. Okay, so no more single step, no more conditional breakpoints. The same that we did with the link debugging, you will be able to do the same as you saw in this video, in your code. And this is amazing, because now you can control, we talked about controlling the debugger, now you can control everything without even doing single step. Okay? We will give you a collaborative debugging, so you can share the debugging session with another person, even asynchronously. So you do a debugging session, and everything is kept, and now you can chat and tell the other guy, look, in this position, in this loop, in this specific place, I have this problem, in a chat with other persons. Okay? And we will save it in your source control. We will be actually part of the DevOps, of your DevOps system. So for example, we will give you inside, for example, inside team system, the online TFS will give you an add-on. So you will be able to open a bug, even a bug that happened in the history, and see what's happened there, and see the chat that you had. We will give you a way to put, you see this work item, the debug work item, so you can have a debug session in your work item, also for code dump that comes from the production and from the cloud. So you will be able to take a dump that happened in the cloud and do a real debugging using the same values from the cloud, and even changing the code. So we like resurrect the code, we like put life to that code.
2 minutes left, maybe.
Okay.
May I ask you a question?
Okay, so let me sum up and give. So as you saw, we talked about debugging. We talked about what is a debugger. We saw the API of a debugger. We talked about the principle that you need to be systematic. And I showed you Visual Studio as a debugger, how to collect evidence. I showed you Oz code that really helps you and really saves you time. And I also talked about the future. Actually, it's the near future. About that the debugger will be that while you're writing your code, you will also do the debugging, or it will be something that you do together because you'll see the future. And that we will let you debug dead code from the cloud or from the production, taking the dump and doing actual debugging, and we will integrate everything into your source code and DevOps process. Okay, thank you. So if you have questions before the clapping.
Could you please open Slido?
Yeah, I have it here. Should have it. Yeah. Good question, the first one. Does Oz code work with Rider? Not yet, but we visited them in München about 3 months ago. We talked with them about integrating Oz code with Rider. It will also let us debug monocode. So stay tuned. It will happen. It will take a bit time. Do you like Java and why? I actually mostly like C#, C++, not so much Java, but it's okay. It's okay language. But we also talked about porting Oz code. First, it will be probably JavaScript. This is the first additional language. Then Python, Java, and other languages will be ported. Is it possible to debug multi-threading code? It's very hard to debug multi-threading code. Actually, Visual Studio gives you several debugging windows for multi-threading. It gives you a parallel watch, so you can put a variable and see the different values of that variable in each of the threads. We talked about how Oz code can assist in debugging code, and we have some ideas about what to do. At least surfacing the fact that you are now running under an async await, and there is an awaiter that waits for you, or if you are in a deadlock situation, but we didn't implement it yet. Can the Visual Studio debug with the same quality as the old one? I don't understand the question. Can the new okay, maybe I understand. The old one is the very old one, probably. There are two debugging engines in Visual Studio, a very old one and the new one, which is new from Visual Studio 2015, I think. And there are some missing parts, missing features, but most of them are there now. There are some other advanced parts that let us in Oz code do the future debugging, the predictive debugging. There is a virtual virtual layer that let us, it calls VIL, that let us execute code without producing side effects. So this is what we do in the new engine in Oz code. What do I think about Martin Fowler? I will not answer this question. He's a good guy. Okay, so again, thank you very much. You can if you like. There are brochures here that you can take to get Oz code for free for several months to you and to your company. So you got it. Shoot me an email. I will upload if it's not uploaded yet, and just play with it. Tell your friends. Thank you very much.
Thank you.